Good day. This is Crystalline May Largo, a member of Group 4. So this presentation discusses power surge protection devices, or we call SPD, and grounding systems, which are essential in protecting electrical systems and equipment. In any electrical installation, sudden increases in voltage called surges can damage appliances, disrupt operations, and even cause safety hazards. These surges can come from internal sources like switching operations or external sources like lightning strikes. To prevent damage, engineers use surge protection devices or SPD to control and limit excess voltage, grounding systems to safely discharge unwanted electrical energy into the earth. Understanding these concepts helps ensure system reliability, equipment protection, and human safety. The next is the concept of surge. A surge is a sudden and temporary increase in voltage, current, or power in an electrical circuit. It has a rapid rise and gradual fall. It is also called a transient waveform. A surge is like a spike of electricity that appears quickly and disappears after a short time but can cause serious damage. There are sources of surge that came from two main categories. The first type is the internal sources, and the second type is the external sources. So, the internal sources originate within the electrical system, which are switching of electrical loads, example, turning machines on or off. Second, magnetic and inductive coupling, and third is the static electricity. The second main category is the external sources. These come from outside the system. It has two main types, like direct lightning and indirect lightning. But external sources are usually more dangerous because they involve very high energy. The next slide is the causes of surge occurrence. There are two major causes, the direct strike and the indirect strike. So the direct strike is lightning directly hits the structure, equipment, power lines, and produces very high voltage around 20 kilovolts or more, and a very high current up to hundreds of kiloamperes. This is rare but extremely destructive. So, second is the indirect strike. Lightning hits nearby areas, not directly the structure. Surge travels through power lines and communication lines. It produces voltage around 6,000 volts or higher, occurs more frequently than direct strike. Even if lightning doesn't hit directly, it can still damage equipment through connected lines. So, next is the surge current waveform. This explains how surge behaves over time. So, there are types of waveform. First is the 10/350 microsecond waveform in direct lightning. The 10 microseconds is the time to reach the peak, and the 350 microseconds is the time to decay to 50%. It represents very powerful lightning currents. Next is the 80/20 microseconds waveform. The 8 microseconds is the rise time, and the 20 microseconds is the fall time, common for indirect lightning or switching surges. The third one is the 1.2/50 microseconds voltage waveform. The 1.2 microseconds is the rise time, and the 50 microseconds is the decay time. It used for voltage surge testing. So next slide is talking about what is SPD, or surge protection devices. An SPD or surge protection devices is used to protect electrical equipment from surges, limit overvoltage, reduce electrical noise. It is also called as TVSS, or we also known as transient voltage surge suppressor. It works by diverting excess voltage safely away from equipment. Next slide is the direct lightning strike. The direct lightning strike is directly hits a structure or line. It produces very high energy surge and uses 10 over 350 waveform. The effects of this are the severe damage to electrical systems, electronic devices, building structures. This is the most destructive type of surge but less frequent. So, the next light is the indirect lightning strike. This strike is near the structure, not directly on it. Surge enters through power lines, pipes, communications cables, and uses 8 over 20 waveform. The effects of this is less severe than direct strike, but more common and still damaging. This is the most frequent cause of surge-related damage in electrical systems.
Classification of protection zones. So first is the lightning protection zone LPZ 0A, LPZ 0B, LPZ 1, and LPZ 2. So we have example specific target facility. LPZ 0A is the facilities outside the lightning rod protections range except for the outside lights, street lights, and security lights. And the LPZ 0B is the facility inside the lightning rod protection range out of the outside facilities such as penthouse receiving facility, air conditioning outside devices, airline failure light, and antenna. LPZ 1 is the facilities in the inlet part inside the building receiving the transforming facilities, MDF, and weak electricity terminal box. And LPZ 2 is the individual shielding area inside the building such as trunk line, distribution board, common facility control panel, IS room, and disaster prevention room. So this protecting electrical and electronic system from the impacts of lightning is the primary objective of the lightning protection zone. So as it passes through various zones, it gradually lowers electromagnetic interference and source voltage. This guarantees dependable system performance and helps shield delicate equipment from harm. In general, it manages lightning energy and securely disperses it before it reaches vital devices. So, type and class A application of SPD. We have three types of SPD. We have equipotential bonding or lightning current SPD. Yeah, test class, test waveform microseconds, we have 10 over 350 current. Then application niya is main distribution word. Then next is over voltage or SPD to OB. This class is 2. Then 8 over 20 current. Then application is sub distribution word. Uh, over voltage is SPD or TOB. This class 3. Then combination of 1.2 over 50 voltage and 8 over 20 current. So application is terminal equipment sub distribution word. Surge protection device technology. So first is gas discharge tube or GDT. So gas discharge tube, which are specific type of lightning or surge arrestor. These are commonly used to protect sensitive electronic and telecommunication equipment from high voltage and transient like lightning strike. Then transient spark gaps to 100 kiloamps TSG. So transient spark gaps, which are devices typically used in residential or industrial electrical system to protect equipment from voltage spikes and lightning strikes. Then metal oxide varistor or MOV. So varistor is a voltage dependent resistor that protects electronic circuits from high voltage spikes and surge. It acts like a safety valve for electricity. So we have highlights of IEC 61643. So first is electrical test, second residual voltage with 8 over 20 microsecond current impulse from front of wave spark over voltage 1.2 over 50 microseconds. Then limiting voltage with a combination wave open circuit voltage measured mechanical test, terminal and connection, polling test, environmental and material test, heat resistance test. So the purpose of this IEC 61643 testing is to confirm the functionality and dependability of source protection devices or SPD. The device ability to control surge voltage and manage lightning impulse is tested electrically under physical stress or mechanical tests verify the robustness and longevity of terminals and connections. Tests of the device's materials and environment make sure it can endure heat and other challenging circumstances, offering long-term and secure protection. Worldwide SPD testing standards, we have IEC 61643 or dash 11, low voltage surge protective devices, part 11. So we have surge protective devices connected to low voltage power system requirements and test methods. We have UL1449, we have SPD or surge protective devices. Then IEEC 62, test specification for surge protective devices for use on the load side of the service equipment in a low voltage to 1000 volts and less AC power circuits. We have types of surge protection devices. First, surge protection devices is SPD. Then you have two types. We have box type SPD and then DIN rail SPD. So in DIN rail SPD, so they have class 1 plus 2 SPD MOV and TSG base. Then sa class 2 AC SPD, we have MOV base. Class 2 DC SPD solar PV system. Telecommunication SPD. Then data protection SPD. Power SPD in DIN real type, we have type 1 plus 2 plus 1 plus 2. We have 10 to 350 microseconds and 8 over 20 microseconds. And type 2, we have plus 2, 8 over 20 microseconds. And type 3, oh, plus 3, 8 over 20 microseconds and 1.2 over 50 microseconds. Note that above SPD are main variants or further divided into poles and current rating. Power SPD or DI in real type, it is features a combination of concrete, wood, and glass elements giving it a contemporary and elegant look. The structures incorporates greenery or multiple levels, creating a balance between nature and urban living. So, typically usage. We have main distribution board, sub distribution board, and low voltage equipment. So, in main distribution board, we have main distribution board will have class 1 plus 2 SPD with class 2 SPD. Then, in sub distribution board, we have mainly class 2 SPD to protect from over voltage. Then distribution board, we have install one more or SPD distance is greater than 30 meter. In application, we have electricity panels, railways, industrial control system, and building system. So, protection system function by safely channeling and dissipating lighting energy onto the earth rather than attempting to stop it. So, this underscores the importance of employing both internal protective measures such as SPD and external system including grounding and lightning rods because Indirect surge can damage electrical system even without a direct strike. A layered approach to protection is essential. Proper grounding and banding are critical to providing low resistance pathways for lightning currents. Consequently, an effective lightning protection strategy necessitates a comprehensive, integrated approach to those safe management and dissipations of high energy transients.
So let's move on in grounding system. Grounding, also called earthing, is the process of connecting an electrical system or device to earth ground so that excess or unwanted electricity can safely flow away. Example, in your house, the third pin and in the plug, the round one, is a ground wire. If a fault occurs inside an appliances, the current flow through the wire into the earth instead of shocking you. So grounding is like giving electricity a safe escape path. If sometimes goes wrong, like a short circuit, the current goes into the ground instead of through you. So then the objectives of a grounding system are: first is to ensure correct operation, second is to provide safety, third is prevent damage, fourth is dissipate lighting strokes, five is to stabilize voltage, and the last is to divert stray RF energy. So neutral wire. What is neutral wire? So neutral is return path for an AC circuit which is supposed to carry current in normal condition. If electricity flow to a device through the live wire, it's returned back through the neutral wire. So second is neutral wire is always assumed to be uncharged in active circuit. This neutral wire is given to ground by grounding to make a second terminal of neutral wire in at zero potential. So the neutral wire can carry current and have voltage, so it's not always completely safe. To keep it zero potential, it is connected to the ground earth at source like a transformer. So ground and earth wire. First is, what is ground wire? Earth or ground is a safety concern against leakage or residual currents in system via less resistant path. The ground, the earth ground is used for safety. It provides a low resistance path for leakage or residual currents to flow safely into the ground instead of passing through a person. The second is current flowing in the ground where this current is not direct coming from live or phase wire, but is from secondary links which was not in touch with live system in normal condition. Third is different between application of ground and earth wire. If both will mix, then the earth wire, which is not supposed to carry any current in normal condition, may have some charges across and will become hazardous. A safety ground desire has two objectives. First, to provide means and carry electric currents into the earth under normal and fault conditions without exceeding any operating and equipment limits or adversely affecting continuity of service. Second, to ensure that a person in the vicinity of grounding facilities is not exposed to the danger or critical electric shocks. What are the three main of grounding? The three main are equip grounding or safety. So protect people from electric shock by connecting the metal parts of appliances to the earth. Its fault occurs current flow safely to the ground instead of through a person. So second is system grounding. Connect parts of electrical system, usually the neutral, to the ground to stabilize voltage level, ensure proper operation of system during normal and fault condition. So the last is lighting surge grounding. So it provides a direct path to the earth from high voltage surge caused by lighting, protect buildings and electrical equipment from damage. Earth, earth or ground basis. So types of grounding system may different types. Available choice depends on the local condition required function. So simplest form in a single state mostly used for. First is lighting protection. So lighting protection is a safely channels lighting into the earth to protect structures. Second is standalone structures. so provide independent grounding for isolation buildings or system. Third is backup for utility ground, serve as an extra path if the main utility ground fails. So the last is ground road group, typically for lighting protection on large structure and protection around potential hotspots such as substation.
So soil characteristic. So soil type. So soil resistivity varies widely depending soil type from as low 1 ohmmeter for moist, loamy topsoil to almost 10,000 meters for surface limestone. So moisture content is one of the controlling factors in earth resistance because electrical conduction in soil is essentially electrolytic. So next is an ground and earth wire. So system, recommended earth resistant ohm, natay line current. So natay 0.5 to 1, then the low voltage is 5, then medium voltage is 2.5 and the high voltage is 0.5. So substation earthing system. So makita na to sa picture no nga naay ang katong sa step untouched voltage, then the grounding grids. So step potential. Step potential, it is equal to the difference in voltage given by the voltage distribution curve between 2 points at different distance from the electrode. A person could be at risk of injury during a fault simply by standing or near the grounding point. So touch potential. So touch potential, it is equal to the difference in voltage between the energized object and a point some distance away. The touch potential could be nearly the full voltage across the grounded object if that object is grounded at a point remote from the place where the person is in contact with it. So ground testing methods. Differing earth materials will be affect from the effectiveness of the grounding system. The capability of different earth materials to conduct current can be quantified by the value P, resistivity in 2 meters. Resistivity measurement should be made prior to installing a grounding system. The value measured will have an effect on the design of the grounding system. So next is a methods of decreasing ground resistance. So decreasing the ground resistance of a grounding system in high resistivity soil is often a formidable task. Recently, some new methods have been proposed to decrease ground resistance. So methods of decreasing ground resistance. So first is a fall-off potential or 3-point methods. So it's a simply way to measure how good an electrical grounding earthing system. So you use 3 rods points in the ground. So example, ground rod, the one way you are testing. Current rod placed far away. Then a potential rod is placed in between. So how it works? So a test instrument sends a small current from the ground rod to the current rod. Then it measures the voltage between the ground rod and the potential rod. Using voltage and current, it calculates resistance Ohm's law. So next is a Wiener's methods or 4-point methods. It's another simple way to measure how well the soil conduct electricity, mainly used before installing grounding system. So you place 4 metal rods in a straight line equally spaced. Rod 1, current in, then the rod 2, voltage measurement. Sa rod 3, voltage measurement, and the rod 4, current out. So all rods are spaced evenly 1 meters apart or 2 meters apart. So how it works? So a tester sends current through the outer rods sa 1 and the 4. Then it measures voltage between the inner rods, then sa 2 and the 3. Then it calculates the soil resistivity. So next is a soil treatment alternatives. So ground enhancement material cement like compound, non-corrosive, extremely conductive, installed around the electrode, easy installation, and permanent. So the last is a conclusion. So a grounding system and power surge protection devices are essential for protecting electrical equipment and guarantee human safety by successfully limiting overvoltage brought on by lightning strike and switching activities. Surge protection devices or SPDS shield delicate system from harm. In the meanwhile, grounding system stabilize voltage and lower the chance of electric shock by giving fault current a safe way to dissipate into the earth. These systems are a crucial part of any well-designed electrical installation because they work together to provide a dependable initial line of protection.